there are these things called logical operators in C++ that allow us to construct some pretty crazy test conditions for our if statements. So we can look for some pretty complex things when we're decision making. So for instance, we can have this if statement that say is looking for a particular number, and say this number has to be positive, and the number has to be even, and the number has to be greater than 80, and the number has to be less than 130, and the number cannot be 90, or say the number could be negative, but if it's negative, it has to be odd. And so this is a pretty crazy test condition looking for a positive even number between 80 and 130, but not 90, or a negative odd number. And if we happen to find that number, then great, we execute the code under this if statement as always. And well, we get this job done with the help of our logical operators. Now, logical operators are pretty similar to other operators that we've used in the past. For instance, we've used the assignment operator that takes variables like x and assigns them values like 7. We've also used relational operators that compares two operands and say puts out a truth value if 4 is less than 5. And if it's true, well, it puts out a 1. And if it's false, it puts out a 0. And, well, the logical operators are pretty similar to the relational operators. They also put out truth values of zeros and ones, but instead of testing integers and floating point numbers and characters and strings and stuff, they test other truth values. And so let's dive right on in and start talking about them specifically and get some intuition for what we're dealing with here. So we got 3 different logical operators. We have what's called the AND logical operator, and it's denoted by a couple of ampersand signs. Then we have the OR logical operator, which is denoted by a couple of pipes. And then we have the NOT logical operator, which is denoted by an exclamation mark. Well, the AND one, let's say that we create this scenario, and I think this scenario will help us understand what's going on here a little bit better. Let's say that we're looking for a number that is both positive and even. It has to be both of these things, right? Well, let's say that we have a test run on this number, and this test returns that indeed the number is positive. So it returns a true value saying that this number is positive. Well, we throw down our AND logical operator here and we compare the other test. Let's say that we have this other test that runs to see if the number is even, and say that the number is indeed even, and so it returns a true value. And so we're looking for a number that is positive and true, and these other tests both return true values. And well, when we AND together both of these values like this, we indeed found what we were looking for. We found a positive and even number, so this returns true here. Now, on the other hand, let's say that we run these tests again on a different number, and say that this time the number comes up, the first test comes up false because the number is negative, right? But let's say that the number is even still, so the second test comes up true. Well, this is a negative even number. It's not exactly what we were looking for, a positive even number, and so comparing those with the AND logical operator, we get a 0 out for false because, well, it's not exactly what we were looking for. Now, on the other hand, let's say that we were to run these tests and, true was returned for the first test saying that the number was positive, but now false was returned for the second test saying that the number was odd. So we found a positive odd number this time, which still isn't what we were looking for because AND requires just a perfect find. It requires that the number was positive and even, and so this isn't what we're looking for. Once again, we found positive and odd, and so, well, the AND logical operator returns a 0 here. And now the only other combination that we could possibly find is if the number was negative, so the first test fails with a false, and the number was odd, so the second test fails as well. This is the exact opposite of what we were looking for. We were looking for positive and even, and we found negative and odd, so of course this returns a false here. Now, the or statement syntactically looks very similar, except for it uses its own symbolism, of course. But it works a little different behind the scenes or with its logic. So, for instance, with this, we're looking for a positive or even number. Either condition will do. And so once again, let's run through our test and let's say that we find a positive number. This time we're going to use the or logical operator symbol. But we find a positive number and the number happens to also be even here. Now, either one of these conditions could have been true, but both of them are true, and that still doesn't change the outcome. That's just even better. And so when we find a positive and even number, we were just looking for one or the other, either positive or even, and well, both of them are true, so the outcome is still true here. And so, well, let's run the next test. Let's say that we find a negative number. Well, it's not looking great so far, but either one could be true, and we'll still return a true from the or logical operator. But let's say it's negative, but it's even. So, well, that is still true. Only one of the conditions has to be upheld with the or logical operator. We would have been fine with the positive number, or we would have been fine with an even number regardless of its sign. And so we found an even number regardless of its sign. And so, well, that is true here. And so now, let's say that we find a positive number. So we've already found one of the conditions. We know that no matter what the next condition is, that this thing is already going to return true, because or statements, all they want is one of the things to be true. And so, well, the number's positive. It doesn't matter if it's even or odd. And so, well, let's run this, and yep, just a positive number will do. As a matter of fact, the only thing that will make an or statement false is if everything about the or test is false. And so let's say that we find a negative number that is odd, right? So both of these tests fail and both return falses, and well, there you go. There's the one false that you get out of an or statement, because everything is false in this scenario. Now, not is probably the easiest one out of all of these, because it literally is just it switches whatever the truth value is. And so, for instance, let's just say that we're dealing with not here, and then drop down a line, and then here we'll just see out whatever not true is. Well, not true, easy enough, is false. And so when we run this, we see not true, and that's, well, false there. And then, as you can imagine, not false, well, that's the same thing as true. And so there you go. I mean, here is our truth there. Not false is true. And so that's how the logical operators work in a nutshell here. And so we can do a real simple example before we go. Let's say that we have a program that, wants to find a positive even integer. And, it'll say that it's found that integer if it is positive and even. Otherwise, it won't do anything at all. And so very, very simple program. And so we'll say that we'll say cout, enter a number to the user, right? And then we will have them cin that number into some variable number that we have not created yet. And so we'll say have this integer number going on here. And then we'll say if number is greater than 0, meaning that it's positive, and we have to say that the number modulus 2 equals 0, meaning that it's even, right? Then we're going to see out to the screen that the number is positive and even, and then drop down a line. And so now when we run this to see how this works, so enter a number, so we'll enter in a 2, it is positive and even, so that works so far. So let's enter in a 3 here. here, and nothing happened because it's positive, but it is odd. And so let's do a couple of other test scenarios. Let's say that we're going to do a 0, which is neither positive. Well, it is even, so I mean, but it still doesn't count here. And so let's say -1, which is both negative and odd, so that certainly doesn't count. And so negative and even, well, there we go. Nothing happens. Only when you enter a positive and even number do you get positive and even printing out, and our code works like it should using the and logical operator in this particular scenario. And so obviously you can string these together to be much more complex, but this is just a quick example of how you might use one of them. All right, we'll see you in the next one.